Okay, I'm running off this inverter, statpower inverter. It's got 12.3 volts in the battery, 450 milliamps. It's drawing. So I'm running on the battery now and an inverter. And I'm stepping it down. It has 115 volts into it from the inverter. Coming out is 61 volts AC, so 115 volts AC in, 61 volts AC out. I tried a whole bunch of AC caps in parallel, which lowered the draw when I had it from the grid, but it doesn't do anything except make the draw go way up. And I tried a whole bunch of different caps. So this doesn't work with this inverter. Does not work at all. Coming out of the run cap phase is 87.5 volts and 110 milliamps circulating with a 4 UF cap. And so that's how this works. With this. I don't know how I'm going to tweak this some more. The AC cap. Here, let me do the AC cap and I'll show you what happens. I'm putting a 2 UF across here. All of a sudden it's gone over 500 milliamps. I'll do a 4 here. This is what worked with the grid powering it. 4. I have to change to 20 amps. See, look at that. It's huge. If I take this off, this is in 20 amps right now. Here it is with it. And it doesn't make any more here on the output by putting it here, so it's kind of useless when you're using this inverter. Okay, so one moment, I'm going to run it straight from the inverter with no transformer. Okay, I got it. Transformer is now not connected. Not connected. And I just have the inverter running the motor with a 4 UF run cap. Now I got 210 milliamps circulating, 148 volts. A lot better VARs in the run cap phase. However, it's drawing 0.63 amps. This is in 20 amp setting because my DC, the next one over, only goes up to 500, so I have to use this. So, there's that. Now I tried to put one of these AC caps in parallel of the AC coming out of the inverter. You know, whoops. Whoops, I just shorted that accidentally. Okay, watch what happens when I put like a... This is just half a UF, 0.5. That brings the draw up to 73 and doesn't do a thing over here on the run cap side. Let's try a 2. It's a little bit dramatic. Okay, I have a 2 UF connected across the AC feeding the motor. Look, it goes all the way up to 1 amp. Take it off. Goes back down to 0.63. So, the input with this, with a 4 UF run cap, is 630 milliamps times 12.3 volts. That's the input with this inverter. Now let's try with a 3 UF cap. Here's 3 UF instead of 4. It's now 130 milliamps circulating and 130 volts over the run cap. And what do we got? Look at this. Okay, I think we dropped this down. Remember, it was 0.63. We dropped this down to 0.45, the input. So that's good. So I'm messing with that run cap. So we lose some on the VARs coming out. Again, let's go to 4 UF run cap. 4 UF run cap is 210 milliamps, circulating 148 volts, 630 milliamps draw from the battery. Take off this 1 UF. Whoops. Okay, now we're back to 3 UF now on the run cap. 130, 130 volts. 130 each way. That's 130 milliamps, 130 volts over there. And we got this down to 0.45. Isn't that nice? So, that's about all I can do with this, running this on this battery and this. And right now we are straight from the inverter to the motor. No transformer. And like I said, I tried to do that trick with the 4 UF cap across the transformer output, and it doesn't work with this inverter. So, I guess that's about it. Look what I got here. I got my scope ready to go. But I'm not prepared for it. Hopefully tomorrow. I want to see what the phase shift is with this. Maybe I'll be saved by a big, very low power factor. And so I can say the watts isn't so much. I'd like to see what the power factor is for the inverter and also with the grid. So that's about it. Okay, thanks for watching.